All right, good morning. It's Mr. McMurray here on K. Murray. That was My Sweet Lady by John Denver, one of the true classics by one of the true classic artists. John Denver and Weird Al, of course, being the top two artists of all time. Now, we're going to do a lever checkup. This is basically about torque for the most part. Also labeling the class as a lever at the end, but we'll talk about that in a minute. All right, so if you look at number one, it says how many grams must be placed at B to balance the 100 grams that is at A. All right, so we have to remember, first of all, what is torque? Torque is equal to the arm length times the force or the weight on the arm, okay? So in order for this to be balanced, the two torques have to be the same. So it doesn't really matter what these are. You can say inches, centimeters, whatever, but the units of length, 1, 2, 3. So for this side, you need to write your formula to find the torque, and that would be 3, which is the length, times, let's just make them centimeters first to do that, so we have our units. Okay, let's say it's 3 centimeters times 100 grams. Of course, that's going to give us 300 centimeter grams. All right. I can't do a little dot thing on here, so I don't sure I do that little dot for the plus. But anyhow, there you go. All right. So that's what we have on this side. Now we need to equal that on this side. Well, what do we know on this side? We know the length is 1, 2, 3, 4, 5. So we know that 5 centimeters times x is going to balance, which means it's going to be equal to the same side, which is 300. Okay, and so basically, if we divided both sides by 5 centimeters, we would get the answer that x is equal to, and you would put your answer right there. Don't forget your units. Since this is weight, it's going to be, or mass is going to be in grams. Okay, so you would have however many, let's just write that, you know it, and I know it is 60 grams. All right. So make sure you do that, then box your answer here so I can tell for sure where your answer is. All right, circle it or do something with the drawing tool. Always go to drawing over here, boom, and either draw a box around it or circle it or something like that. All right, now this is the same kind of thing you're going to do here and similar here. Now they're going to do some things a little more complicated, but a little different, but still about the same, okay? Now, the first thing it says, if you were to add a third nickel, so let's say we take a third nickel, all right, which I'm not sure how good my drawing is going to be here. Not bad, not bad. Okay, so we have a third nickel right there, okay? Now, we want to take off this one, so I'm going to try to just scratch it out there so it doesn't exist anymore. And I want to know where can I move that third top nickel to make this thing balance? Okay, well, you would multiply 1, 2, 3 times, let's just say 3 nickels. Okay, so the distance of 3 times 3 nickels gives you a total of 9. All right, and this one has 1, 2 distance times 2 nickels is 4, and then plus wherever you put the nickel and how much torque it has. Okay, so for example, if you put that other nickel right here, boom, it would be 1 times 1, which is 1. 1 plus 4 gives you a total of 5, which does not equal the 9 units of torque you have over here. So you're going to figure out where to put that nickel so that you end up with a total of 9 so that this will stay balanced. All right. Now, this next one, you have 7 pennies all lined up. The fulcrum would be at the edge of the desk. So that would be your fulcrum. And so it's 1 unit times 7, so it gives you 7 units of torque on this side. Now, the question is, can you put 1 penny on this side and make it balance, or make it tip? I'm sorry, can you lift it and tip it over? And so you would say, yeah, can't, yes or no. Well, the farthest you could put it would be right here at the end, so you would figure out the torque for that and decide if it would be enough to lift that or not. With 2 pennies, okay? And it says if you can do it, tell how far they would be from the fulcrum. So it would have to be at least however far away, okay? Same way with 3 pennies. Could you make it balance or lift the pennies up over here, lift up or unbalance and tilt off? And so can you do that with 3? And if so, tell how far away they would have to be from the fulcrum. All right. And then these are kind of the same kind of things here. You have the ruler here, weight right there, And it's asking you, could you do it with a weight less than 100 grams? And if so, how? 10 grams, and if so, how? 20 grams. You get the idea. All right. This one is just a mobile, like what we're going to be doing for your special project, which I need to put one of those online for you. And same kind of thing. The distance would be here, and then the weight would be there, and that would tell you the torque, and it has to equal the torque on the other side. All right. Now, there's some things with crows. Once again, the fulcrum, of course, would be on the shoulder here. And then you have a crow on one side, and you have the crows on the other side. The crows all weigh the same amount, so we would figure that. All right, and so on. Now, starting with number 13, these are all levers. So what I would like for you to do is put a F for the fulcrum. All right. E for the effort, where you're putting effort, in this case would be on the handles. And R for the resistance. In this case, you're moving the blades to cut paper, so that would be there. And using our FRE, we know that since the fulcrum is in the middle, this would be a first class lever. Remember free or fre, if you prefer. All right. Fulcrum in the middle is first class. Resistance in the middle is second class. And if the effort's in the middle, it is a third class. So if you label FRE on each one and then put what class of lever they would be. All right, just make sure there's a broom. This is a shovel, and this is if you were shoveling snow and throwing it over here, okay? Not digging out of the ground, scooping something up and throwing it out. Okay, so you're tossing it. All right, think about that. All right, then you have a paper chopper, you have tweezers, you have a wheelbarrow, you have pliers, and finally this is a nutcracker. You squeeze down here to crack the walnut, looks like to me. Although around here we usually use them for pecans. But anyhow, that's okay. Nutcracker. Not to be confused with the ballet. That's a whole different nutcracker. But anyhow, you get the idea. All right. So that's basically it. Fill yours out, turn it in, and if you have any questions, let me know. Have a great day.